Hello class. Today we're going to do some practice dimensional analysis problems, and I'm going to walk you through each of the problems. Practice problem 1. A piece of metal has a density of 5.62 grams per centimeter cubed and has a mass of 32.0 grams. What volume does the piece of metal occupy? I've given you the density equation. D is equal to m over v, which means density, D, is equal to m mass over v volume. First step in any problem should be to identify variables. So you were given D, and it's equal to 5.62 grams per centimeter cubed, and you were given mass, m, which is equal to 32.0 grams. The next thing you need to do is to plug it into your equation. So rearranging to solve for volume, V is equal to mass, M, divided by density, D. And so plugging in, we have 32.0 grams divided by our 5.62 grams per centimeter cubed. Now always check your units because that will tell you if you've set things up right. So if I cross out grams over grams equals 1, and now I have 1 over centimeters cubed, which is going to be centimeters cubed, and that's what we want because again that's going to give us the correct unit for volume. And so then going ahead to solve that, our volume, V, why isn't it writing? Our volume, V, is going to be equal to, when I do the division, 5.69395 and a whole bunch of other things. And so now I have to look at sig figs. Remember that density is an exact number. That's something you look up in a table, so we don't worry about that for sig figs. We look at the only measurement we were given, in this case 32.0 grams. That number has 3 significant figures, so we count across. You always start counting from the left. 1, 2, 3, the 9 is our last digit. The number immediately following it is a 3, which means we don't have to round it up. 4 and below, we let it go. So we end up with a volume equal to 5.69 centimeters cubed. And I circle it just for fun, and that solves our first problem. Okay, so our second problem is another density problem. This time we're given a metal with a density of 11.83 and a volume of 41.3 centimeters cubed. And now we're asked to solve for mass. So one more time, we're going to identify our variables. So D is equal to 11.83 grams per centimeter cubed. And in this case, our volume is given, so V is equal to 41.3 centimeters cubed. Draw a line to keep it neat. Now we're solving for mass, so we know that density times volume equals mass. So mass is equal to our density, which is 11.83 grams per centimeter cubed, times our volume, which is the 41.3 centimeters cubed, and then canceling centimeters cubed over centimeters cubed, we're going to end up with our mass in grams, and so our mass comes out to be 488.579. And now a quick check before I put in the unit and round. We had the density, which doesn't come into play, and we had a measurement that had 3 sig figs. So 1, 2, our third sig fig is the 8. The number immediately following it is a 5, and a 5 and above we have to give it a shove, so that means we round the 8 up to a 9, so our mass is going to be 489 grams. And I draw a box around it because I can. Okay, this next problem is a classic dimensional analysis problem. We are given a measurement in inches, and we are asked to go to millimeters. So using our ACE, Analyze, Calculate, Evaluate method, I have to come up with a plan. So I'm going to plan, and I'm going to go from inches to centimeters, because I know that there are 2.54 centimeters in an inch. And then once I go from centimeters, I can go to millimeters. There are 10 millimeters in every centimeter. Always give yourself a plan. Always begin with the given, and then work your way methodically toward the unit that you want. So we're going to start with 58.0 inches times 2.54 centimeters for every inch times 10 millimeters for every centimeter. Now please notice that when you set up your conversion facts, you always have to put the unit that you want at a particular step in the numerator, that's on top, and the unit you're getting rid of in the denominator, that's the bottom. So here, inches divided by inches cancels out, goes away. Centimeters divided by centimeters equals 1, it goes away, and we are left with millimeters, and that's what we're trying to solve for. Yay! So now I'm going to do my multiplication on my handy-dandy calculator, and I end up with 1,473.2 millimeters. So now we have to look over at our number of sig figs. The given had 3 sig figs, so I start counting from the left. 1, 2, 3, our third significant digit is the 7. The number immediately following it is a 3. 4 and below, we let it go. So we're just going to end it at 7, but we can't lose the magnitude of the number, so we're just going to throw in a 0 as that placeholder. So that means I'm going to end up with 1,470 millimeters. And we'll put a box around it because we can. And again, we did not lose the magnitude of this number. Okay, we're up to problem 4. This problem asks how many milliliters are in 2 gallons of milk. Now, you'll notice that I've given you a conversion fact right here that I looked up for you in a handy-dandy table. We know that 1 liter is the same as 1.06 quarts. So if I can get from gallons to quarts, then I can get to liters, and then I remember that there are 1,000 milliliters in a liter. So let's set out our game plan. We have gallons. Sorry about that, not very good A. Gallons are going to take us to quarts. From quarts, I can leap over to liters, no pun intended. And from liters, I can get to milliliters. All right, so now, sorry, that was a messy L. So now, we're going to draw a line, and then we are going to methodically start with our given and work our way toward our final number. So 2.00 gallon times 4 quarts in a gallon. Notice, unit I want is on top, unit I am getting rid of is in the denominator, so it cancels. Then I have to go from quarts to liters, and I know that I have 1 liter, remember unit I want on top, is the same as 1.06 quarts. And then finally, there are 1,000 milliliters in every 1 liter. So now quarts cancels, and then liters cancels, and we're going to be left with the unit that we want. Now, some other things I like to point out here. This is a multi-step calculation, so let me change colors of ink here for a second, because I can. And let me point out, when I plug this into my calculator, it's going to be 2. That didn't change colors. Oh well, I'll keep going. 2 times 4 divided by 1.06 times 1,000. That's what you're going to plug into your calculator, okay? So now what that results in, when you do that, is 7,547.1698. And a bunch of other numbers that I'm way too lazy to write. So now, before we go any further, let's go back to the given, and you will notice that our given had 3 count 'em significant digits. Trailing zeros are only significant when the number contains a decimal point, and by golly, this number contains a decimal point. Woohoo! So that means we have to count over, starting always from the left. 1, 2, 3. Our third significant digit is that 4. The number immediately following it, however, is a 7. 5 and above, we give it a shove. That means our 4 must be rounded up to a 5, and then everything after it becomes a 0. So our answer is going to be 7,550. And then our unit is milliliters. Please resist the urge to put in a decimal point, because if you were to put in a decimal point, all of a sudden that number would have 4 significant figures instead of 3. Okay, last problem. We're going to go from miles per hour to centimeters per second. So we're going to go from miles to feet, feet to inches, inches to centimeters, and then hours to seconds. Here goes. So 35 miles per hour times 5,280 feet per mile times 12 inches per feet times 2.54 centimeters per inch, and then times 1 hour is 3,600 seconds. So miles, feet, inches, all cancel out. Hours cancel out, so we're going to end up with centimeters per second. It's an S. So when we do all of that, we end up with, it equals 1,564.64. And sig figs, we need 2, which would be right there. So that means we're going to end up with 1,600 centimeters per second. So with a complex variable, you want to remember you're going to take the units one at a time, and you should be successful.